Now we're going to study a transformation that's a little bit different than the ones we've studied before in that this transformation is not rigid. Remember the rigid transformations we studied, we were basically taking an image and moving it around. We take a pre-image, we apply a transformation to it, and we get an image. And though the pre-image and the image were the same size, they were just at a different location. Well, now we're going to look at this thing called a dilation, which changes the size. The best way to understand a dilation maybe is to think of shadow puppets. And I've got some pictures here to refresh your memory. These shadow puppets, remember, you hold a flashlight, put your hand and shine the flashlight on your hand, and it projects something on the wall. Well, in this, maybe it's a dog or a horse or something like that. But in this particular description, the flashlight is what we would call the center point. Your hand is the pre-image, and then this thing on the wall is the image. So to look at something kind of a little more mathematical example, let's consider this thing right here. Now notice what we've got here is we've got the blue, this PQR right here. Okay, this PQR. And then we've got this red over here. And notice here I've got P, and up here I've got P prime. So P and P prime. And what we want to do is think of that center point, C, as a flashlight. It shines against this triangle, and I get this P prime, Q prime, and R prime. Now, this is an example of a dilation, and notice we want a way to measure the dilation. In other words, we want to figure out, well, how do I measure what's happened here? Is the image bigger or smaller than my pre-image? Well, here's the way we're going to talk about that. We're going to take the new distance from the center point right here. Okay? So from C to P prime. In other words, this is the distance from the center point to the image. And I put that on top. I get a 5. And then on the bottom, I put the original distance from C to P, and that's 2. So what we get there is we get 5 halves. Now, we call this a scale factor. A scale factor. And if we get a scale factor bigger than 1, then we say that the image is bigger than the pre-image. And that's kind of intuitive to think about in the context of wall puppet or shadow puppets. But dilations, the process doesn't have to give you a bigger image. Look at this one here, this one. Notice if we take, now we're always going to take the new distance here, the distance from the center to the image. And notice here it's 3. The old distance here was 6, so we get a 1/2. Now we've got a scale factor of 1/2. That means our image is smaller than our pre-image. Okay? But that's how we find the scale factor. Now let's look at these down here. Here we've got 2, okay, over 3. Okay? So notice that's a reduction. Okay? So the blue is the original, the P, and then the P prime is what we ended up with. Over here, we take the new, which is 2, over 1, and we get a scale factor of 2. Okay, now let's look at another example here. Let's suppose we have a rectangle, and it has these ordered pairs, 2, 2, 6, 2, 6, 4, and 2, 4. And we want to apply a dilation with a scale factor of 1/2 to that. Okay, so let's see what happens. Let's look at these points and see what happens to these points. I'm going to cut all of them in half, all the coordinates in half. So 2, 2 becomes 1, 1. And let me plot that over here. Here's 1, 1. 2, 4 becomes 1, 2. Let me plot that over here. 1, 2. There we go. 6, 2 becomes 3, 1. Okay, there we go. Plot that. And then 6, 4 becomes, 3, 2. So 3, 2. Now here is the result of that dilation. right here. Okay. There we go. Now, so that's us applying a 1/2 dilation. Now, I want to show you something here. Let's look at this distance here. This distance here. This is like our P, right? So let's think about that distance. That's going to be the square root of 2 squared plus 4 squared, right? Because the origin here is the center point. And that is the square root of 20, which you could reduce that. You know, this is 4 times 5, which is 2 square roots of 5. Okay, so this distance is 2 square root of 5. Now let's look at this distance here. Well, that distance, let's look at that one. And let's see what that is. Well, that's the point 1, 1, 2. So this is going to be, see here, 1 squared plus 2 squared, and that's the square root of 5. And notice the ratio here, the square root of 5 over 2 square roots of 5. In other words, you know, we're just doing this, CP prime over CP is 1/2. And that's what we were thinking we would get. I mean, that was the whole idea here. Now, I want to, you might be saying, well, what do we mean? I mean, what is the result? What does this new rectangle here have to do with the old one? It's certainly not 1/2 the size. I mean, if we talk about the area of it, it doesn't look like it's 1/2 the size, but let's think about this. Let's think about the perimeter of the bigger one, okay? So let's think about the perimeter of the blue. Well, the perimeter of the blue is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's 12. Now, let's think about the perimeter of the red. Well, it's 1, 2, 3, 4, 5, 6. 6, which is 1/2 of the big one. You can see now how the scale factor kind of came into play there. But the thing is, we can take note of the fact that the pre-image and the image after dilation are going to give you similar figures. Yeah, similar figures. And the ratio is going to be the same as the scale factor. Yeah, so that's an interesting thing to take note of.